So this talk is on Hibernate. And as you probably know, every talk is like a flight, right? That gets you from one place to the other. And our flight starts from this little nice ORM idea and goes straight to hell. My name is Boychuk. I grew up in the village in western Ukraine, not far from the Carpathian Mountains. I fell in love with mountains when I was a kid, and I still really love them now. And the only thing in my life I love more than mountains is my family. Together with my beautiful wife and our little son, we live here in Kyiv. I work for a company called GlobalLogic as Java consultant. I have around 8 years of experience with Java. And now I'm primarily interested in architecture and design. Apart from that, I'm a little bit obsessed with education. I conduct courses and trainings because I really like working with real people. And I believe that right conditions help people to learn effectively, to work effectively, and to grow naturally. So in case you have similar interests, I'll be happy to chat with you later during the day. Most probably you'll be able to find me near the GlobalLogic stand over here. So this talk is most suitable for people who have experience with Hibernate but don't know much about its details, okay? So in particular, we're going to discuss the ORM idea and how it's implemented in Hibernate. And we will talk about things like PersistenceContext, ActionQueue, and Flash, okay? So we will check some code examples using pure Hibernate and some Spring-related examples as well. I've already told you something about myself, and I would like to learn something about you. How many of you have been using Hibernate for more than 2 years? Okay, keep your hands up if you like it. Okay, so like half of, okay, cool. So do we have people that think that Hibernate is a pure evil? Okay, so I have to say some terrible things about Hibernate to make you happy today, right? Good. So ORM, this super cool idea, right? The business logic of your application lives in Java objects, where your data and behavior are beautifully combined together. But you cannot trust your memory, you cannot trust your RAM, right? So you have to persist your data somewhere. And of course, you want to put your data in some safe and accessible place. But even today, in most cases, it will be a relational database, okay? But relational database knows nothing about your object. It does not understand object. It knows about tables and rows, foreign keys, primary keys, indexes. It does not understand object references. It doesn't know about your Java lists, and it completely misunderstood the inheritance. So it's totally different model. And I guess you know that famous list of mismatches between object-oriented and relational model, right? Yeah, okay. So and what we do in enterprise Java development whenever we have a problem, we get a framework to fix it, right? So we get this Hibernate, we put it in our application so we can fix all those mismatches for us. I would like to work with objects, and I don't want to work with SQL tables and row. Basically, I would like to store an object, read an object, update an object, and remove an object. I don't care, right? Hibernate should do it for me. In one sentence, we can say that my object is linked with a database row in a certain table. And basically, all the changes of the state of my object should be transformed into a SQL query that will reflect those changes on the database. And all of that is done via ORM magic. And this is the idea behind the Hibernate, okay? This is the idea. And we're going to see how this idea is implemented. Before we check the code, we should say that you know that you can use just the Hibernate, right? Or you can use Hibernate via JPA, which is the spec, right? And since most people are using it via JPA, we're going to use it via JPA as well. So our code examples will be using JPA. And I would like to show you how it's all organized, so you can then be focused on example itself and don't worry about the rest of the configuration. So we have this Maven module with 4 modules, where the first 2 are kind of helper ones, and the second and the third one have the example itself. We have an entity module here that contains huge amount of entities. We have 1 entity actually, and we have a persistence XML file here as well. As you know, persistence XML is a default place, a default location where JPA looks for its configuration. Okay, you should not be worried about these things. The only thing you should probably know is that we're going to use in-memory H2 database. Okay, so this is the entity, and we have this util module where the first thing is a simple data generator. I would like to store nice data, so I have a little data generator that will generate an account with some kind of real fake data. And also we have this JPA util. If you were using JPA, you know that even in order to perform super simple operation like persist, you still need to write a lot of boilerplate, right? Because you need to have an entity manager factory, and then you will need to create an entity manager, and then you will need to start a transaction and perform your operation, and then you will need to commit your transaction or roll back it, and finally you will need to close your entity manager. So like good piece of boilerplate, and we have that boilerplate implemented in this class basically, right? So we have all the boilerplate here, so we can pass the lambda that we want to perform within the scope of the transaction to this method. And we have one method for that case if you don't need a return value, and the second method for that case when you need a return value, okay? And we are initializing an entity manager factory here, and this thing is reading that persistence XML. So entity manager is a thread-safe factory of entity managers, just in case you didn't know that. So we're going to use these 2 methods in all the Hibernate-related examples, okay? Still good, okay? So the first example is super simple, and I decided to start with a super simple example and just check how far can we go with Hibernate with no resistance, okay? So super simple example is we generate an account, we perform persist using lambda that will go to that method. And basically that's all. The first example, I guess, works, right? And that's all I got for you today. Thank you very much. The same with load, right? You have stored an entity, then you do, using lambda, find by ID, and Hibernate generates for you basically a SQL select, right? So it's going to generate a select over here. Good. And the same with remove, right? Not really. Because you cannot remove entity by ID. Okay? You cannot. Because Hibernate doesn't allow you to do that. You have to pass the whole object in order to remove it. So in case I don't have an entity, I cannot remove it. I have loaded first. But in case I have an entity, right? I've stored it here, so I have an entity. And I would like to remove it. Can I remove it? What is the correct answer? The correct answer is it depends. Okay? Because if you're a Java developer, it depends is your default answer to any question, right? So it depends. And it depends on what? So we're going to try to remove it, and in this case, it's not going to remove it, right? It's going to throw an exception. And we will go a bit, we will check some of the Hibernate source code. We're not going to go like do too much into that. We're not going to go deeply into the Hibernate because it's going to kill us. So we will check it a little bit. If you'll find that, so we're going to find for the, if you're going to check the Hibernate method that is responsible for persist, you will see this beautiful switch here, right, that checks an entity state. So apparently Hibernate has some entity state, and you probably know that if you're using the Hibernate. So for us, it's important to check how Hibernate manages that state. And the most important thing regarding the state in Hibernate is this class called PersistenceContext, which, not this one. Right. We have this stateful persistence context. And as you can see, it stores like huge amount of different things. And basically, Hibernate has its own super complex internal structure in order to manage entity states. Like for instance, it got this thing called, I cannot find it. Okay, I'm going to do this. Entity entry context. Okay, so this thing is some kind of a custom linked list of a managed entries. And Hibernate has this concept of entity entry, which is basically structure that it uses in order to handle and track an internal state of each managed entity. But you can forget the thing, and you can remember only that every time you create a session, in Hibernate it's a session, in JPA it's a entity manager, right? That's the same thing. So basically, session extends entity manager, and like entity manager is an API, and session it's kind of an implementation part. So okay, so every time you create a session or an entity manager, it creates this stateful persistence context, and it creates a lot of different things in order to handle and manage and track internal entity states. And as you can see here, it's one-to-one relation between session and persistence context. So what does it mean to you is that every time you do something like persist, Hibernate does not generate a SQL statement for you. It creates dozens of objects and put them in different places. And all of those objects live in your application until you close the session or until you clear the session. But we actually rarely clear the session. We usually close it, right? So all of those objects will live in my application until I will close the session. And for us, it's important to know where are the boundaries of that persistence context, right? It's kind of important things if you're a Hibernate developer. So, and in this case, the boundaries of the session and the boundaries of the persistence context is this util method, right? Because every time we call a util method, we create entity manager and we close it. So the boundaries of the persistence context is here. And every time you close a persistence context, all the entities that were added to that persistence context became detached. Okay, so in our example was remove. Our example was remove. This first thing had its own persistence context, and when we went out of this method, this account became detached. So in order to remove it, we will have to do first. We will have to attach it back to this, attach it to this session, and we're going to use method merge. And it's going to return a managed account for us, and we will pass that managed account in order to remove it, okay? So now it's going to generate a delete statement. Okay? It works. So just one takeaway from this part is that a session is linked to a persistence context that stores huge amount of data and has very complex structure in order to handle and track the states of our managed entities. What is also important here to notice is that every time you call method merge and you pass a detached entity to that method, it generates a select statement as well. Okay? So in order to attach entity back to the context, we are calling merge. And merge will go to the database and would load a corresponding record from the database. And then it's going to use that entity you provided, and it will apply your changes on top of that data that it loaded from the database. So the only thing you should remember, because we're going to check the same thing in Spring, is that method merge generates an additional select. Okay? Okay. So, and this example is pretty clear because it uses one entity and it uses just the Hibernate. We don't have any complexity on top of that, right? So let's gonna check some kind of more real-world example with Spring. And let's try to find the boundaries of the persistence context in Spring using the JPA and Hibernate. How many of you are familiar with Spring Boot and Spring Data? Okay, so more than with Hibernate. Crazy. So we have this. I have super simple examples, so everyone can like read it and understand it. Okay. So in this case, we have Spring Boot with two starters: Data JPA and Web, and we have very simple app with configuration that when the application starts, it generates and puts 10 accounts to the database. So we just have some data. And it gets this REST controller with two methods, get all and remove by ID. And we have repository, and we have this service. And we're going to play with this service. So this service finds account by ID, and then it removes it. So let's try to run this thing. As you can see, it generates 10 insert statements. So we will now we'll hit that endpoint in order to check if it works. So we have the 10 accounts there, and we're gonna hit the delete endpoint to check if remove works. So the first account is gone. Okay, so it works. And the question to you I have is, where are the boundaries of the persistence context in this example? This method. Transactional proxy. That's very good answer. Thread. Okay. So, and what is the correct answer to this question? It depends, right. So it depends, and it depends for sure. You all see this transactional annotation, and you're like, hey, transactional annotation. So, of course, because we have Spring Boot, and we put this transactional annotation here, it's gonna auto-configure a platform transaction manager for us, and it's gonna create a proxy, and it's gonna inject the transactional logic into that proxy. And because we have the data JPA starter, it's going to use JPA. It's going to use actually JPA transactional manager. So it's going to inject that JPA related logic to this service. And you may think that like you have the transactional here and default propagation level of the transactional is required, right? So you may think that it's going to check if we already have a session, we're going to use it, otherwise we're going to create it, right? So it's kind of a logical approach. So we will just try to remove this transactional annotation, or actually we'll try to comment it, and we will do the same again. What do you still think will happen? It depends. Okay, so if this account becomes detached, then this delete may throw an exception, but it won't, because in Spring there are a bit smarter, so they implement it properly. And if you check this method, it checks if the session contains an entity, it passes it. Otherwise, it calls merge, okay? Kind of a smart approach. So in this case, if it's calling merge and we are having detached entity, we may expect an additional select here. Do you agree? So we remove the transactional, so we don't have a transaction here. And as you know, all the JPA repositories are transactional by default. So if you go to the repository, this repository is transactional by default. So we will definitely have a transaction for this method and session and for this one. So we assume that here account is loaded and it becomes detached, and then we pass it here and it's calling merge and it's generating additional select. Who think it's going to happen like that? Only one person? 2, 3, 4? Like it's kind of what else? What are other options? What do you think? Okay. So let's just check then. I'm going to remove this thing and we're going to call delete. So we're expecting select, but we don't have one. We don't have that select. We don't have that select because in this service, this account does not become detached. And I guess somebody knows that. So we have a couple of people that know. Kind of. So we can change that because, and that's why it depends. Apparently, why it works like that, because in Spring Boot we have this open entity manager in view interceptor that is registered in Spring Boot by default. And what the thing does, it actually intercepts all web requests. And it's going to intercept your web request and it's going to create an entity manager for you. And then it's going to bind that entity manager to the current thread. So during the whole processing of the web request, you're going to have an open session, which is kind of crazy if you know what is an open session, because it's kind of like not very nice thing. So why they did it like that, actually? Because of the hipsters, I guess. Or I guess just a lot of people started using Spring Boot, right? And those people would try to implement a simple REST API. So those people would create a couple entities and then would create a couple controllers, and then they will return entities from the controllers. And Spring will use a Jackson in order to create a JSON using those entities, and the Jackson will access fields, and some of those fields would be lazy, and they would throw a lazy initialization exception. So people would be angry, and like I started using a super cool Spring Boot framework, but it throws me a lazy initialization exception, what the heck, and so on. So they decided by default to register this interceptor, so everyone is happy now. But what I think they also presume that like people that are using Spring Boot, Java guys, are smart people, and they learn tools they are using, so they will learn the thing, and then will eventually turn it off, right? Because if you're using it by default, you have your session open during the whole processing of a web request. It does mean that all those like complex structure of the internal state live in your application during the whole processing of a web request. And in order to keep that session open, you cannot release your database connection as well. So it's keeping your database connection open, and it's not releasing it to the pool, which is also kind of crazy. So I'm just wondering how many of you know, how many of you did know that it works like that? Okay, so we have like, I guess we have a lot of people, because in most cases people don't know that. It's kind of a cool thing if you're trying to bootstrap with boot, which is kind of logical. But if you're building an enterprise application, that thing may be critical for you, right? So you should be aware of that. And the most takeaway from all this thing is that you should know the boundaries of the session. Regardless of the project you're using, regardless of you have Spring Boot or if you have Grails, you just should know the boundaries of the session, and you should actually see them in the code because it matters. So, what is also important is what you should care about the boundaries of the persistence context. Because things like first level cache are basically work in the scope of the persistence context. Persistence context itself is a first level cache. So every time you try to load an entity, it goes to the persistence context at first, and then it goes to the database. And in case it can find the entity you're looking for in the persistence context, it's not going to go to the database. You have actually two maps, by ID and by natural key. So Hibernate can find entity by those two things without going to the database. And what is also important is Hibernate ignores fresh data that it gets from the database and uses the one that is in cache. So even if you will load a data from the database and you have fresh data, but you also have a corresponding entity in the persistence context, Hibernate is going to ignore that updated record, and it's going to still use the one that is in cache. And we also have things like lazy loading that also works only in the scope of the persistence context. We also have things like dirty checking that also work only in the scope of the persistence context. We also have things like orphan removal, and we have other stuff. And all of them work only in the scope of the session. That's why you should care about the session boundaries. And they don't work basically outside of this session. Who's angry now? No? Okay. What else we can find in that Hibernate? So you may notice that every time you perform methods like persist or remove, it does not generate a SQL query synchronously. You may notice that. And if you open that method, if you go there, you will see that method persist does not generate an insert statement. It fires an event, a persist event. And it becomes much more interesting because we have events now. So, and actually it's like, it works like that. You have an event every time you perform a persist or remove. And that event is then handled by event listener, okay? Which is processing that event. And eventually that event became an action. An action represents the SQL statement, okay? And then that action is not performed synchronously. It's only collected to the action queue, okay? That's how it works. So, and you may think like, why do we need such a complex structure? So it seems much easier at the beginning, and then it became more and more and more complex. So, and you're thinking like, why do we need that? Basically, in order to protect our data access layer from ourselves, because you know how tough we can be. Imagine someone is removing entity and then saving it back again. So in that case, Hibernate will not generate a statement at all. So we're gonna check the remove entity and save it back. And we have this, so we stored an account, and then we open new session. And we do this, we find account, we call remove, and then we call persist using this account. So if we'll run this thing, you will notice that it's not gonna generate a remove and then insert statement. Right? We have a select, and then we have these two sentences and no SQL queries. Okay? Because it's protected by Hibernate asynchronous mechanism. And if you open this if you open that thing, and you will find on persist, and you will check its logic, and it says if the state of the entity is deleted, it's going to get a session, get its action queue, and unschedule deletion. That's why we won't have a delete and insert statement again. Okay? So that's how it works. In general, what you should remember from this is that you always have a session. Okay? In your enterprise application, your session is linked with your thread, right? Because you have like a lot of users going to your server if you're not using reactive. And then you have, in each thread, you have a session. And that session has this thing called PersistenceContext. And it also has the thing called ActionQueue. And PersistenceContext, we have in order to track internal entity states. We have super complex internal structure in order to track that state. And this action queue we have in order to track and store SQL queries. We're not performing them right now. We are collecting them to the queue, and we're going to perform them later. Boom. So just to simplify, when you fire an event, and you are firing events by calling methods like persist. When you're firing event, it does this. It updates a persistence context first, because if you call persist, it's going to create different things, and it's going to put them in different maps and lists inside that internal structure. So for instance, you're going to have your entity in your first level cache. And what it also does, it creates an action. So those things are kind of two the most important things that it does. And all of those actions are collected here in ActionQueue until you call the flush. So the flush is the mechanism that gets these actions from the queue and that performs them against the database. You can call flush manually by calling method flush, or Hibernate can does it automatically for you. And if you think that flush is straightforward, it's like just a flush, it's not, because it's also a complex mechanism. Hibernate can does flush for a certain type of actions. It can do that in different on different stages during the workflow. So it's not straightforward. And what is also important, that ActionQueue has its own order. You may think that if you call remove and then you call persist, it's gonna perform delete and then it's gonna perform insert. But it won't, because it's gonna collect those actions to the ActionQueue, and ActionQueue has its own order. So if you will do first delete and then insert, actions will be sorted in a different order, and it will do first insert and then remove, okay? I cannot read from your face if you know that or not. How many of you did? Sorry? Yes, yes. I have a code example for that, but did you check the GitHub with the code examples for this session? Okay. So what you may think is it's a bit more too much. Who think it's too much? We have such people, okay? And yeah, it's kind of too much because the idea is really simple and the implementation is like, and if you go to the source code of the Hibernate, you will go crazy browsing through that code. But I believe that like no one is removing entities and then inserting it back again. And even if someone does, who cares? It's not that important. But we have this complex mechanism not just because of cases like we have insert and we have delete and insert. We have other important things like update. So we've been talking about insert and select and remove, but we didn't talk about an update statements. And according to that super nice idea ORM, we have to update our database record every time the state of our object changes, right? And you may think like how Hibernate can know if my entity changed. How can it know if the field of the entity changed? And this is another important thing, because in order to do that, Hibernate need to create a snapshot copy of your entity. So basically every time you load an entity to the session, Hibernate creates a snapshot copy of the corresponding record, which is basically an array of object. And then it's gonna defer the comparison until you will do the flush, and then it's gonna compare the actual entity state and that snapshot copy, and will probably create an update action. And why it does it like that? Because you probably don't want to have an update statement every time you change a field, right? Because during the business, like the workflow of the business logic may be pretty complex, and you may be changing different fields multiple times, and you don't want to have SQL updates for all of those changes, right? Because it's going to kill the performance. So Hibernate wants to defer that action, and that's why it creates a snapshot copy. And this mechanism that is doing that thing is called dirty checking, right? And there is much more. So if you dive deeper into the Hibernate, you will find interesting things regarding lazy loading, cascade, orphan removal, the relationship between entities, ID generation, and other stuff. You will find a lot of different things. And if you plan to work with Hibernate, I guess you should do that, because it's kind of important. And in order to do that, you will look for a trusted resource. I have a clicker. Okay, so you will look for a trusted resource. And what I can recommend this guy. He used to work, okay, we can give him applause. He used to work as Hibernate advocate developer, and he is a Java champion, and he wrote a great book that can learn you a lot if you are interested in that. So I really recommend that if you plan to work with Hibernate and if it's kind of an important tool for you. And he's also working on this thing called Persistence Optimizer. It's kind of a tool that you can add to your project, and it's going to automatically detect all the issues you have with Hibernate, and it's going to provide you some logs with the corresponding messages, okay? But personally, I feel that this optimizer should be built inside the Hibernate, not this separate tool. But still, I believe it's worth checking it out. To summarize, ORM is a simple, nice idea, but it's very hard to implement it. And in my opinion, Hibernate is not good or bad, it's just complex. And you should be thinking about that before you start using it. And I also think that you should be considering another options. And one of the options is Spring Data JDBC. Recently, I've been at Spring One conference, and I visited this talk, which is called the Domain-Driven Design with Spring Data JDBC compared to Hibernate. And this is the link to that talk. So, and why it's important, because, for instance, if Spring Data JDBC is sufficient for you, then you don't have to deal with Hibernate complexity, right? On the other side, if you need a powerful ORM framework, then you can rely on Hibernate. But in that case, you will have to become its close friend, right? Because you cannot use Hibernate efficiently if you're not his friend, if you don't know basically a lot of its internals. That's the thing you should know. And if you will forget everything we were talking about today, I encourage you to remember just one thing, is that you should know the tools you're using, okay? Because it's important. Personally, to me, it doesn't make sense to Google the same exception over and over and over and over again. It just doesn't, okay? you should know the tools you're using, especially if that tool takes part in your core business logic. It manages your data access and even can have an impact on your data consistency, right? There is time to laugh and there is time to be serious. And we're not laughing right now because it's kind of important. So I just encourage you to know the tools you're using. And we have this amazing thing which is called brain inside our heads. And you know how little of our brain's power we use? You know why? Because we are Googling exceptions during the whole day. And it's really sad. It's sad because we should use our brain for proper work, like analysis and creativity. And in order to do that, we should stop fighting the tools we're using. We should know the tools we're using. I believe it will bring much more value to your customers, and it will make you feel happier. And that's what I wish you today. Thank you all very much. And we have still time for questions.
Can you show the book again, please?
Show the book?
Yeah, high performance.
I can show you the monkey.
Hello? Hello. Hi there. Thank you for a very good talk. You show a lot of creative stuff. Many people don't even think about it. And it seems like we move in the complexity from the managing SQL, for example, to the Hibernate. To know in the Hibernate system to use it efficiently. And so can you please share your opinion? In which situation do we still need to use Hibernate?
Okay, so it really depends on how much expertise you have in Hibernate. Because I believe if you have expertise in Hibernate and if the team has expertise in Hibernate, then in a lot of cases they can use it. But if the team doesn't have an expertise in Hibernate and start using it as a default solution, it's gonna run into a lot of trouble during the development. So it depends on expertise for sure. And it's kind of a de facto standard. So like people are starting using Hibernate by default. They are not thinking. And I just feel that we should start thinking and we should analyze it. Because really, even with microservices, we have much less databases and much less number of entities. So in case of microservices, it's even easier to start using things like Spring Data, JDBC instead of the Hibernate. But the main question is team should think before they do it. Okay?
Yeah, thank you.
Thank you.
Can you share your Git repository?
Sure. I guess it will be attached as well with the presentation, but I'm gonna GitHub. Oops. We have questions, so I'm gonna check it, but we still have questions, right?
Yeah. Hello. Thank you for your speech. It was really interesting. And you mentioned that context boundaries are pretty clear when we are speaking about common REST API, but what about reactive case?
I don't want to answer that question because I don't have like much experience in reactive, so it won't be useful. Okay.
Okay, I got it.
Yeah.
Thank you.
Thank you for the question still.
Some question about interfaces. For example, we have pretty clear interface in Spring Data GPA, and it's very simple to use. But for example, all this stuff that I have in my, for example, imagine small project, and I just insert, and I don't need any kind of stuff of lazy loading and so on, but I need to use interface Spring Data GPA. Maybe you advise some tools and some alternative of Hibernate for using interface of Spring Data GPA.
Okay. Have you used Spring Data JDBC? It's not JDBC template. It's a different thing. So Spring Data team have built a a data repository that has similar method to the JPA repository, but it's implemented using the JDBC. So I guess that it's what you're looking for, probably.
Spring Data JDBC,
yes.
Right?
Yes.
Okay, thank you very much.
Yes, you're welcome.
Okay, let me rephrase my question. Is there some simple way to get understanding about context boundaries from the logs, maybe, or somehow else?
To get what?
Understanding what are the context boundaries. So some log case, context started, context closed, and things like this, maybe.
Yeah, you can enable different level of logs in the Hibernate, and you can check that. Or you can like read the book, and you will learn a lot of different stuff.
Got it.
So Taras, thank you for your speech. It was very interesting. You mentioned that by default in Spring Boot the event listener is enabled, which opens the session. Yeah. Do we have some simple property to disable?
We do. And I had to show you that, but I forgot. So in application properties or in application YAML, you can do this open in view false, and it's gonna disable that interceptor. Okay, so it's gonna work as expected if you will disable it.
Okay, thank you.
Yeah, you're welcome. If you're like, yeah, it may, bro. Okay.
Do you think that the concepts behind JPA and Hibernate are at all theoretically correct? I mean, you can do things to a certain level, but then you will come to examples where this caching that implicitly happens kind of gets out of control. And I have still don't know if it's like just the example that I don't control it enough, or if it's like conceptually part of the idea that it will just happen like that. Thank you.
Okay, so what I think is, and what I encourage people, that is if you are using Hibernate, if you will use it, you should learn a lot of its details, because it's gonna create you a lot of problems otherwise. So conceptually, it's hard to say because relational databases are pretty old, and that model is very old. And we are trying to build this ORM, which is like very complex to implement. So, and indeed, it creates a lot of troubles for people that are using Hibernate. So the only thing I see is you should learn a lot of. If the idea is right, I don't know, it looks like cool, but then you start implementing it and using it, and you run into a lot of troubles. So I guess it's a kind of a trade-off. So if you feel that you gain more than you lose with Hibernate, that's fine. But what I observed is a lot of people feel that they lose more than gain when they're using Hibernate, you know. So that's yeah, thank you. Thank you, guys.